Okay, we stopped into this slide. We'll start from the next one. So next one is basically two practice problem. Okay, so students should be able to practice those and come up with the values of the k. So two different one in here. I'll just give you an hints. Then maybe in the future I'll solve them and add another video or things like that. If the BOD2 of a waste is 119, and BOD5 is 210. What is the BOD rate constant? K or capital K doesn't matter. So in this case, I would say it's very easy to practice. If it is BOD2 is 119, say for example, then equal to L0, because we don't know the L0, into 1 minus e to the power minus KT, then I will say T is 2, K is K, small k, I'm using small k. This is one equation. The other equation would be 5-day BOD is 210, right? So 210 equal to L0 into 1 minus e to the power minus. Then since it is 5-day BOD, we'll say 5K. Okay. So now I have two equations, equation 1 and equation 2, right? Equation 1 and equation 2. So, but I have a two unknown. What are the two unknowns? One is L0, other one is the K. So the best way to solve these two unknown and two equations, so do some operations so we can get one and come up with the other one. Okay, so in this case, I can see very easily, I can divide 1 by 2. That means this divided by this equal to this divided by this. So L0 cancel out, and 119 by 210 would be point something. So then you can have a left hand side and right hand side. So this equation doesn't look like any kind of explicit equation. So what we do in this case, we use the trial and error method or iteration method. Okay, so we assume a k value, then come up with a value with the right hand side. That means the 1 minus e to the minus 2k divided by 1 minus e to the minus 5k. If I know the value of k, then definitely I should be able to calculate this, and this divided by this will give me a value. Then we'll compare the value with 119 over 210, and if it is close, then we accept it. So it's a trial and error. So to start from one point, those who took the numerical methods will know better on that. Basically converging and diverging. If it is coming towards that, then first assume a value. For in this case, I come up with k equal to 0.275. We can start with k equal to 0.1 and see what is the value, how far it is. Then we consider k equal to 0.2 and see whether it's going closer, right? If I take 0.1 and come up with a value, and if I take 0.2 and come up with a value, looks like with the value with k 0.2 going towards the ratio of that, then definitely I know that I have to go further, right? Then if I go further, let's say I try with zero point 0.3 and it looks like no, now it's not closer, it's going down the other way around, then we know that we have to come down. So that's the way we do this one. The other one, second one, is basically very similar. If the BOD5 of a waste is 210, looks like it's the same problem. And the BOD ultimate, in this case, BOD ultimate is given, is 363. Then what is the BOD rate constant, K or capital K? In this case, it should be very easy to do. 360, we have 210, right? 210 BOD5 equal to ultimate BOD means L0, 363, right? Then 1 minus e to the power minus 5k because it's 5-day BOD. Okay, so now I can do 1 minus e to the power minus 5k equal to 210 divided by 363, right? So this one may be becoming a very small amount. So 210 divided by 363 is 0.57, is 0.57. Okay. So now what I can do here, I can do e to the power minus 5k is equal to, we can write 1 minus this value. So that means this value, right? So this minus this value. So this becomes 0.42, right? This becomes 0.42. Okay. Now, so this is my equation came out to be e to the power minus 5k equal to like say 0.42. How can I solve it? This is not also explicit. Now, the question is if I take a e-based ln over here, e-based ln over here, then e-based ln and whatever is the base is here is the e, then the power is the product or ultimate results. So if I take a ln in here and ln in here, then this will become minus 5k to the right side will become a ln of 0.42. Okay, ln of 0.42. Now ln of 0.42 is basically will give me an option 0.42. If I take a natural log, it becomes negative 0.86. It becomes negative 0.86. Okay, negative 0.86. Now this negative cancel out. Now k value would be equal to 0.86 divided by 5. It would be 0.86 divided by 5. So ultimately this is becoming like say the 0.86 divided by 5 is 0.172. So it becomes 0.172. Okay, so there's the answer. And I think I gave the answer here somewhere. Probably I did the rounding. 0.173 is the answer. So this should be very simple to do that, right? Okay, so this is a good exercise. Probably I should have more space so that I can do it here, but it was looks like I didn't have enough space. But since I did step by step, you guys should be able to practice that. Okay, now our next topic is the graphical determination of BOD rate constant. So we have to know that, we have seen that, we need to know the K value to run the equation, BOD equation. So here is my BOD equation that is from FE exam handbook, right? Thomas graphical method is the one. Thomas is the one who did first of this thing. After doing all the series expansion, here is the series expansion. You guys have done that in the map, like e to the power x, since it is our negative in here, so if we expand it, most of the time this would be negative, this would be negative, and the rest one would be negative, and also the power would be negative here, right? So power would be negative, maybe things like that. So if I do this expansion, and because of the like factorial higher factorial and higher negative power in the higher level one, so it will become very negligible part of it. Okay, so negligible part of it in this case. Okay, negligible part. Now I will have a two term here. If I use two term here for that, then I'll have a three, maybe just keep two term in here, okay, and use this one and maybe this one. So if I have the three term, then I can rearrange those term like that. T over yt to the power 1/3, k L0 to the power negative 1/3, then k 2/3 divided by 6 L0 1/3 is another term, then also t. So this can be considered as a straight line equation from our geometrical point of view, geometrical background. This can be considered as a y, and this could be considered as a kind of c, and this is as an m. So y equal to mx plus c, right? Y equal to mx plus c, and t equal to x. So here is the one. That means that's what we did. M equal to this, c equal to this. So equation become like that. Now, if we solve the two k on this, because in this two equation, m should be known from the graph, and c could be known also from the graph, right? If I have this, so I can get the m value from here, right, and c value from here. So this would be my c. So if I know my m, I know my c, then only unknown here in two equations, two unknown k and L0. If I solve it, I get a k equal to this and L0 equal to this. Okay, so 410 and 411 equation can be used to calculate the value of k and L0. So that is our main intent, to value BOD rate constant. Okay, so here are some of the explanation that I have here. The procedure for determining the BOD rate constant by this method. First, what we'll do, we'll have the experimental data, whatever the data we have. Then we'll arrange the data, calculate the value of t over yt for each day. Then the plot the y over yt versus t. So this would be in the x direction. This is x direction. This is y direction. Okay. In a simple graph, draw a straight line that would be best fit by I. We can use the Excel. If you definitely, I'll ask you to use the Excel to do the problem solving for the homework. Definitely determine the intercept C and the slope M. Then calculate the value of K and L0 using the equation 410 and 411. So here is the example problem we would like to solve. I have a 2-day BOD 119, 5 days 210, 10 day 262, and 20 day 279, 35 is 279.98. So it's better to have more than 2 data because more data can give us more accurate results. You guys know that. Then what I did, I calculated this one. This one is basically 2 over 119 to the power 1/3. I got this. And similarly 5 by 210 to the power 1/3. I got this. And we calculated all of them, right? All of the 5 data, 1, 2, 3, 4, 5. Then we'll plot it. So I plotted it here. I used Excel, and Excel can give you the equation here as well as the coefficient of correlation coefficient R squared. It looks like 97.8% of the variability of the day has been taken care of by this, right, in this equation. Or manually, what you can do, you can come up with some kind of, like, say, you can use this to find the value of M here, M and 1, the rise over fall, right? So you can get the coordinate here. This coordinate would be what, 35. I think I have used around 34. So around 34, and the other one, T over Y would be 0.5. Okay, so in here would be, this one would be what, like around, I have here it looks like, so I didn't use that one. What I did, I used up to, looks like here is 0. Okay, so here I used it for like a 0, and I used 0.25, right? 0.25 here. So again, if I know this point, this coordinate, and this coordinate, I should be able to calculate that way. The rise would be 0.5 minus 0, or 0.25, right, from here to here, and the fall would be 34 minus 0. So I get this. So this is very close. I use hand, and I got by hand from here is 0.25. I got here 0.2541, and for the slope I got 0.0074 from the equation, and whereas using my hand calculation I get very close. So then I have used this equation 10 and 11 here. I calculated the value of K, I got 0.18, and I calculate the value of L0, I get 363. You remember this problem, right? So this problem, we are probably continuing the same problem that has ultimate BOD of 363. Okay, very good. So then laboratory measurement of BOD, how we do that? The standard method, we use the AWD standard examination method. Preparation of dilution wastewater sample is very important. Preparation of a blank, if we were doing the dilution, incubate the sample and blank at 5 day at 20 degrees Celsius, then measure the remaining and calculate the BOD. So always we measure the remaining is the initial, and we measure after 5 day, and whatever is the remaining, initial minus remaining after 5 day will give you the BOD digital oxygen used. Then if we do any kind of dilution, then we use the dilution factor, multiply with the dilution factor. This would be explained more in the lab. The lab book has a detail of those. This case is just to give you an idea. So here are the dilution, how it works. Sample size, or volume of undiluted sample divided volume of diluted sample times 100 will give you percent dilution, and dilution factor is 100 divided by dilution size. So here are more, here showing more full strength wastewater, that means dilution factor is 1, okay, in this case, but this is had a they are not calling it factor, they are just calling it dilution 1 over 10. I'm calling it dilution factor is 10, but dilution, whenever you call dilution, is 0.1. Okay, so then we have a 1 milliliter taken from here and mixed with 9, make with total 10, so that's going to become 1 over 100. If we do 1 milliliter from here to here, then 1 over 1000, from here to here 1 over 10,000. So this means this is dilution factor is 10,000, 1,000, sorry, 1,110. Whereas the dilution is would be zero point 0.1, okay, concentration 0.1, 0.01, 0.001, 0.001. So we'll explain more of those things, how to calculate those things in there uh, in the lab. Okay, we are going to stop here and we'll